so I'll let you read through it.
You're in our group. Variables.
Yeah.
Database.
And basically the thing is like, you know, this occurs in this plot location, so it's not going to occur in this plot location again. Oh, but I think the rest is pretty straight up forward. You have two different fertilizers, and then you have that have different properties, and you have concentration of them also, high and low. And so you also have aspen and willow. So, yeah. Does that make sense to people? I think that they do it. Okay. Okay. Well, I mean, when designing a database, I mean, well, there is a wrong way to do it, but I mean, there are several different ways, you know, that you can do it. I mean, there are some rules you want to follow, but things could be different. What did you guys come up with?
Archie, you're going to be our spokesperson?
We came up with 1, 2, 3, 4 categorical variables. So one is treatment type, which is fertilizer 1 or 2. Second is level of treatment, high or low. Third is the site, which is Rosy Creek or Bonanza Creek. And fourth one is leaf type, aspen or willow. And then 3 other variables which record the response, the length and width or the level. And then we have a sample ID that is assigned in the field.
Okay. Okay.
By collecting the data.
What for that database would be your primary key or your unique
We
value?
were discussing that, and we think that will be a primary key, the leaf ID, which will be like a sample ID.
Okay.
And we were thinking whether we want the computer to generate that, but then it's better if the person is assigning it in the field. And then in the real database, we could have a record locator, just one record ID, which is automatically generated.
Okay. Okay.
Actually, one thing we were talking about is that since we're using the data from these plots, that the original researcher probably has their own name for each of those plot types or blocks or whatever. So, do you usually use the original names like for the assigned plots or?
Well, I think if you want to, that's one of the things that when you design databases to think about is previous data and compatibility. So if there was, you know, a previous scheme, then I would go ahead and use whatever they assigned for it. You know, like some of the census data, they've already created their own unique primary key, and I just go ahead and use that. You know, and I put that into my database. So I would recommend doing that if it has been done. That's a good idea. How about you guys?
I mean, we pretty much did something similar. We didn't go so far as to specify what kind of variables. Where we did come up with just, I guess that we would have 8 different variables, including, I don't know if the only difference was, like they were talking about, we said it was important, as Anna pointed out, to include the plot number because, you know, as part of the variable because, you know, within any given plot, you're going to have all these different combinations. So, but yeah, we had plot, location, type of fertilizer, concentration, species, and then length, width, and greenness. So we thought, yeah, just by keeping everything in there and separate, that gives us the maximum freedom for our analysis.
Okay. Okay.
And then you would probably separately, there would be like an N or, you know, whatever number each one got, but to make sure that we kept the plot number separate from that because we thought that was important.
Okay.
Oh, actually, we should have probably added one more for like just remarks or comments. Like if something goofed up, someone ate puppy.
That's a good idea.
That's a good idea.
Where the leaf was harvested from in the canopy.
Yeah.
Yeah, you know, maybe it was raining or something that affected, you know, or the sunshine, it was in shade versus light.
It was an aspen leaf finder year.
Yes, exactly. Those all sound good, but one thing it sounds like you guys both did is you have a flat file.
What?
A flat file, and a flat file is basically where you have all your data in one Excel, say Excel spreadsheet, and that's one of the things that probably shouldn't be done. So what I would do if I was designing this, I would make tables that are specific to, that don't combine different, I guess that have a single mindset. So I would, in this one, I would make a table that, for the fertilizer, because the fertilizer doesn't really explain at all the concentration. The fertilizer doesn't explain the two different sites that you're looking at. So I would make, like, one table would have the fertilizer in it, and instead of having to enter the ratio, I would set up that table so that it automatically generates that ratio by using some code. Obviously in Excel we can use code. So I would have one table for that. I would have one table for the concentration, and within that table, then you would have high, low, and then you'd have the concentration variable associated with it. It might seem like this is a lot to do, but think about if you have much more than just two levels. This is a simple example where you only have high, low, but imagine if there was a whole spectrum like 1 through 10, concentration of grams per milligram. So you want to, and then I would have a table for your site. So the table will contain Rosy Creek and Bonanza Creek. And if you have any descriptions about that area, yeah.
What do you mean by table? I mean,
Like
I think of a table as a summary of the data.
it's like
Not
an
data.
access database, and you can relate these to each other. So it's a relationship database. So you're breaking up the data into tables that are specific for different sections of this research, and then you would kind of relate them together. Like one of the tables would be your, say, your greenness table, and that would be kind of like your sample table that you guys were kind of talking about, where you would have what your greenness level was, and then there you'd also put in there whether it was high or low, and then you would link that H or L back to your concentration table. And you'd have in there also the information as far as which fertilizer you used, and that you could link that back to your fertilizer table. Because if you put them all in one table, you're going to keep repeating stuff over and over again. This way you would only have your data repeated in one single table. So like say if you had to go and make changes, you found out the concentration was really different. Since they're related, if you changed it just in your fertilizer table, it would automatically update, say, the table where you actually had your samples for, say, like greenness, and you'd have a table for your length and your width. So it might make more sense once I go through and kind of explain to you. But that's kind of how I would do it. You want to break things up as much as possible and try and
I just
have
realized I
things-
should probably
have things be automatically generated whenever you can. And it's important for each table to have a unique ID. So, like you guys were mentioning, it's a good idea. Like, I would try to code a unique ID that somehow makes sense. Like for the Rosy Creek, I'd maybe call this A and B, and then 1, 2, 3, 4. So maybe the combination of a unique ID might be R and A1, and then maybe A for Aspen again, and L for low. So you can kind of see how you come up with that unique ID.
So then each of your tables is like, for example, your fertilizer one table would be a list of all of your measurements for each of your unique plots.
The fertilizer would just contain a 1 and a 2, and that's your fertilizer type, and then it contains another column for your nitrogen, and they each have their own, and the potassium, and then it contains a ratio. That way, yeah.
So that's a little
like what we were talking about is that we would have a separate table of our keys and definitions.
The question was like how much of this to include in your database versus have kind of separate as the key or metadata or something to